The experiment I chose to do was attempting to recreate a 90,000-year-old bone tool that was recently documented in Bozagar et al.'s 2018 paper. I wanted to find out to what extent does experimental archaeology offer an opportunity to understand manufacture processes of past tool technologies and understand this question by further asking to what extent can utilization of a lithic core enable construction and shaping of bone. So within the experimentation process, I aimed to use this core to create a knife out of a cow rib portion, explore manufacturing efforts, and ultimately understand the challenges to which past people faced. So to do this, I needed to understand the background behind the bone tool which was found and also consider some additional background research. The tool was found in a sealed context at the Dar es Sultan site in Morocco, which is only 260 meters from current coastal settings. By analysing use wear patterns and comparing it with other tools found in this region, Bozagar et al. Realised it showed the Arcturian technology, and using optically stimulated luminescence, they were able to date the tool to 90,000 years ago, meaning it is the oldest bone tool from this technology. The researchers stated that it showed a complex chain operatoire during its manufacture, so in terms of the steps which were taken to prepare and create the tool, and then how it continued to be used. The site's carbonate sedimentations were an important aspect of preservation of bone. However, there is some sediment concreted to the tool. Despite this, this is actually holding the tool together because of its numerous breakages due to use wear. Bozagar et al. Found that this tool was created from a middle section of large bovine ribs, so most likely cow. Its dimensions are 123 millimeters for the whole length, with the tip being just 12 millimeters, and it ranges in width between 18 and 27.5 millimeters. One of the last key points which they suggested was this sort of tool in this technology may have been triggered by resource exploitation patterns, changing perhaps to accommodate a greater breadth of marine resources. So the earliest bone tools are associated with Paranthropus robustus and other early Homo around about 2 to 1 million years ago, and these were used to excavate tubers, termites, work with animal hides, and for working with wood. From here we can see diversity and dispersal of bone tools throughout the African continent, including what was, until now, perhaps the earliest human bone tool evidence at Katanga in the Democratic Republic of Congo, which shows barbed and unbarbed points, which were also constructed from ribs or long bones. The fact that this new bone tool from Dar es Sultan I has been dated to 90,000 years ago also challenges the idea of the dispersal of knowledge and the nature of bone tool creation. Another problem which arises from the bone tool discussion is the suggestion that technologies can have local traditions, as suggested by D'Errico et al. Furthermore, Barton et al. State that there are issues which revolve around categorization of technologies, which is then reiterated by Dibble et al., who says that the Arcturian is actually linked to the Mysterian technology instead of being its own technology. On the other hand, you've got Barton et al. Claiming that the Arcturian is extremely important as an archaeological tracker of anatomically modern human dispersals throughout the continent, and Hublin and McFerrin support this, stating that it may have been this technology and these people that immediately predated the last out-of-Africa exodus. Along with this, though, Barton et al. States that dating techniques are sometimes flawed, and Hublin and McFerrin state that collagen is not always preserved well in African environments. So my rationale for this experiment is that it is important because it provides an opportunity to better understand the Arcturian technology, and since the experiment may well be the first attempt at reconstructing the case study tool, it may provide appreciation for the expertise. By doing this, data for use where manufacture processes and any challenges may benefit future research, and on a broader context, this experiment may offer insight into the abilities of past North African people to adapt with the environment. So this is what I started out with, 2 160mm cow ribs which I had to deflesh in order to get to the bone. After isolating the bone, I measured up the dimensions from the original bone tool and marked them onto my rib. Then, using a lithic core, I worked in a sawing motion to cut through the bone to shorten it. This was extremely tiring and took quite a long time. Meanwhile, I soaked the second rib in room temperature water outside as an additional part to the experiment. According to Gummerson et al., ethnographic records showed that bones were often soaked in water prior to tool manufacture to soften the bone, in order to make easier cuts. I was curious to find out whether 24 hours of soaking could allow for this. However, in some cases, bones were soaked for years, so it seemed unlikely. I actually ended up stabilizing the bone, which helped to keep it still so I could more effectively saw into the bone. However, due to time restrictions, I made the decision to use a modern tool. a saw to continue cutting through the bone. This was absolutely necessary in order to effectively get through the manufacture process. Although this did limit the authenticity of my experimentation and produce different use wear marks as seen in this before when I was using the stone tool and after. And so I used the saw to cut through the bone to shorten it and then to cut longitudinally through the middle in order to get a cortical and trabecular side of the bone. I was unable to figure out how to do this without the use of modern tools, and the paper was vague in this sense as to what tools were used and how they were used. Due to the use of modern tools, the experiment shifted from a process replication focusing on the technological process to an object replication focusing on achieving a visual replication. So this was the result of longitudinal splitting, and as you can see, the marrow on the trabecular side needs to be removed, but it has been transformed morphologically so that its edges are a lot thinner, which would have come into use when trying to create a sharp knife blade. Due to lack of ethnographic research regarding the removal of bone marrow and no information in Bozagar et al. Study, the bone was soaked in hot water for 10 minutes, which resulted in darkening of the bone, and then the marrow was scraped out using a flake. This resulted in the before and after comparison. Next, the core was used to file down the bone to shape the rib portion into something which more closely resembled the original tool. This resulted in the final product. A few different aspects need to be considered in terms of the results. In terms of use wear, the bone endured multiple morphological changes and marks. The first use wear marks arose from defleshing the bones. Since the tendons were attached to the bone, it was often difficult to remove the meat without scraping against the bone. Secondly, use wear resulted from the shortening of the bone as seen in these images. The difficulty to focus the blade of the core on one precise section resulted in striations and cut marks around the general area, as well as an angled cut mark through the bone. As mentioned earlier, the use wear patterns were affected by using a modern saw, which produced more consistent marks. Secondly, the sawing and cutting of the bone resulted in finely ground bone debris and a lot of marrow. Another result which was intriguing was the comparison of dimensions between the experimental tool and the original. The experimental tool was the same tip length but 8 mm less in total length, 2 mm shorter in width, but 17.5 mm longer in its longest width, and approximately the same degree of thickness. In terms of looking at soaked versus dry bone and its ability to be cut easier, there was no difference. This is likely due to the short-term soaking. The amount of time taken to make the tool was also an important aspect of the experiment. Defleshing the ribs varied according to tendons on the bone. However, the overall time was 40 minutes. Then it took an hour to cut the bone using a core, 15 minutes to saw through the remaining area. Sawing longitudinally took 15 minutes also. Soaking the bone to prepare for marrow removal was 10 minutes, and the removal took about 25 minutes. Lastly, the shaping took at least an hour. Firstly, it is evident that use wear patterns are extremely important when considering the history of a tool in terms of its manufacture and use. The types of marks seen using the core was consistent with those found on the original tool, which was suggested to have been created as a result of manufacture and resharpening. As further supported by the case study, D'Errico et al. State that polishing and flake damage of the tool are results of use rather than manufacture, which would explain why the experimental tool was absent of these marks. In terms of manufacture, it is clear that this process requires a lot of time, energy, and expertise to create effective bone knife tools. Due to the limitations in time, I had to resort to modern tools and was unable to test the effectiveness of soaking bone to enable better cutting. Perhaps if I had used a different stone tool, a range of them, or a sharper stone tools, this may have affected ability to shape and construct the bone tool. Some important points to consider when trying to understand the manufacture of the tool are time allocation for optimality. In terms of if they were able to construct a complicated tool, it may indicate less stress, and this is supported by human behavioral ecology. Also, from a post-processual standpoint, each tool may vary according to the individual that made it and their level of expertise. It has also been suggested that population may trigger technological innovation. All these points are necessary to consider in order to understand these past people and how these technologies developed. And so in conclusion, experimental archaeology can offer great insight into the efforts required to create these past technologies. The use of lithics to work bone was evidently a great task which would have required a lot of energy, time and expertise. Although the experiment set out to focus on process replication, it ultimately became one which focused on recreating a visual replica of the 90,000-year-old bone tool. Looking at dimensions and visually, this goal was met with some success. For future research and investigation, I would recommend the use of different or a range of lithic tools, soaking the ribs following more closely with ethnographic standards, and investing a greater amount of time into creating the tool.